Hi, my name is Dennis Sherwood. I'm the author of Creativity for Scientists and Engineers. The book is based on my experience gained over the last 20 years or so in working in the fields of creativity and innovation with all sorts of clients, some in the private sector, some in the public sector, schools, universities, many academic teams too. And over the years, it's been my privilege to have worked with many wonderful people and to generate some stunning ideas together. Much of the academic work has been funded under the EPSRC's Creativity at Home programme, so I thank the EPSRC for helping make that happen. Now, I refer to the book. In fact, I see the book as three books between the same covers, for I develop three different but related themes. One theme is very practical, a series of guides as to how to undertake some key activities. Firstly, idea generation, creativity itself. So I describe a very practical, very easy to use, very effective process for having great ideas on demand now, a process that really works. Secondly, I describe a process for how to judge wisely between strong ideas and weak ones. That's important too, because you don't want to waste time, effort, and maybe money too, pursuing an idea which is fundamentally poor. And thirdly, I describe how to build a sustainable team culture in which creativity and innovation flourish, so that creativity and innovation happen naturally every day. It's the way we do things around here, rather than something that happens once in a blue moon at an off-site meeting. So those three how-to guides: how to have great ideas on demand now, how to distinguish wisely between strong ideas and weak ones, how to build a sustainable team culture in which creativity and innovation flourish, form the core of the book. And they're all illustrated by examples from the history of science and engineering and beyond too, which are the second theme. Stories of great creativity from the past. Kepler, for example. How did Kepler discover that the orbit of the planet Mars was an ellipse, when the current thinking at his time and for centuries beforehand was that all planets move in circular orbits? What did Watson and Crick actually do to win their Nobel Prize for the discovery of the structure of DNA? And why is Sydney Opera House, as we see it today, different from as specified in the original architect's drawings? Those are just three examples of wonderful creativity, examples from which we can all learn. Those examples, however, are all set in the past. So the third theme of the book, and something which is really unique, you won't find it anywhere else, is a set of stories written by 16 contemporary leading scientists and engineers in which they describe in their own words their own creative process. So, for example, Professor Anatoly Zayats from King's College London describes how his research in plasmonics led him to invent a synthetic synapse, a device which mimics the behavior of the synapses in our nervous systems in all our bodies. A second story comes from Dr. Hermione Coburn, the scientific director of Dynamic Earth in Edinburgh, and she describes how she and her team worked alongside a Horizon 2020 project to deliver an outreach program in which the results of the scientific research could be disseminated in truly innovative ways to adults and to children. In engineering, Mike Siemens Flanagan, the director of global engineering for IMI Critical Engineering, starts his story with a herd of cows in Kansas and tells how those cows triggered an idea for a truly innovative valve design. And one more example from the University of Glasgow, in which Professor Sir James Hough and Professor Sheila Rowan describe an aspect of their own research which made a major contribution to the discovery of gravitational waves. So, those real examples embellish the historic examples and enrich the how-to guides. I do hope you will find the book interesting and valuable, and that you will enjoy reading it. Thank you.